Hi folks, my name is Mike Hayes and I work in Edge and IoT Solutions Engineering at Dell Technologies. Today I briefly want to speak to you about a collaborative project we have been working on with Intel and Splunk. And basically the primary aim of this project is to help organizations extend their enterprise IT capabilities right out to the edge. And what we're seeing these days is that there's a huge demand for capacity for IoT solutions. But what's tending to happen is we're getting kind of multiple different infrastructures, software providers, and solution stacks being built. So there's a lot of different technology silos being employed to deliver different outcomes. So what we're working on with Intel and Splunk is trying to create a more distributed, horizontalized edge to deliver multiple different workloads and outcomes. So, a capacity for distributed architecture, extending your data center and enterprise IT capabilities all the way out to the edge. So on this diagram here, very briefly, what this is kind of capturing as a concept is how we envisage this architecture to look. So data coming in here on the left-hand side from your industrial systems, will be things like computer vision solutions, telemetry solutions, and our industrial data platforms like SCADA. So feeding data into your edge. And your edge nodes, we'll show you what these look like in a moment, but these edge nodes are essentially running this edge insights for industrial software from Intel. And what this is it's an open source microservices software stack that allows you to run multiple different workloads on top. So, in manufacturing, as an example, we might be doing things like defect detection, condition monitoring, asset management. We could potentially run different models, algorithms down on top of EII to deliver these workloads. But another unique feature of it is that it's got a message bus. So what this allows us to do is interface other data systems straight into these algorithms. So once we process the data at the edge and we get the insights we need and we get the outcomes we need, we can feed back things like metadata back into our Splunk system. We can feed back our vision files back into our storage platforms. And this allows us to introduce the concept of tiered architecture. So we can do a level of AI out here on the edge node. We can do a level of AI back in the data center. We can do our data analytics with Splunk right out here at the edge, or we can run it back in our enterprise instance that might have more search nodes and more capacity on the back end. So again, kind of extending all of that enterprise capability all the way out to the edge. And that's kind of the fundamental point. So what we've done kind of from an engineering perspective is we've built a solutions demonstrator in our labs in Ireland that basically shows how this thing works. So we've built 4 different hardware platforms, 2 server-based platforms. What's unique about these platforms is they don't need to run in the data center. We can run these down in the manufacturing operations, out near the assets, out in industrial environments. They're certified, they're ruggedized, and they just don't need to run the data center. So a fantastic capability. Also then, in regards to smaller devices, we tested on a precision workstation device, a small form factor device. So, very useful if you want to put compute very near to something like a camera. A good example might be PPE, PPE detection in a small clinic. You could have this bolted right onto the camera, doing and delivering that workload and that AI capability right at the edge. And finally, we also validated on Vmware. So this means we've got a full capacity to architect this thing however we want, okay? We installed Edge Insights for Industrial down on top. It's a nice little graphic of what it looks like here. We installed a demo that Intel provided to us, and this is a defect detection demo. I'm going to show you this as well. A very cool little demo that describes how with a circuit board, basically doing defect detection. So is there a missing, wrong, and damaged component on the circuit board? So a very quick way, kind of computer vision demo that will generate data for the message bus. We installed a Splunk forwarder to move the metadata from this AI model back to the Splunk index. And we also created a connector to send the vision files, the JPEG files that are created by the model, back out to a storage instance in our data center. And finally, then we're working with one of our Dell partners at the moment, IoTech, to create a commercial model around EII. So dependent on you know, your partnership relationship or how you work as a customer, you might have a preference for a commercial model or open source. So with IoTech's help, we're looking to put a commercial model around the EII. So again, dependent on how your IT teams typically operate. So let me quickly flip to a very quick look at this thing. So this is a PuTTY session to one of our edge nodes. It's a PowerEdge XR2, which is a 1U 2-socket Intel-based platform. And this is running Ubuntu server with EII down on top. So again, the nice thing about EII is open source. It's all running on standard frameworks like Docker. You can see here that these containers are running the EII stack. So the top two are my Splunk forwarder and my ECS connector for my storage. Underneath that, then I have the demo container, so the defect detection demo, and also the EII stack itself. Okay, so if we look at the actual demo that Intel provided for us, this is what it looks like. So I described that it's basically doing missing, wrong, and damaged through computer vision on a circuit board device. And you can see here it's clicking through different circuit boards as they pass underneath the camera, picking up, you know, where there's problems. This one is passing, this one is failing. And we can, using the EII message bus, we can output the metadata and the vision files to our enterprise IT backends, or keep them out in the edge where we can put different levels of analytics and our data governance on them. So let's take a quick look at Splunk. So we can see all of our metadata from EII can be fed back into the index. We can create a very nice dashboard that is, you know, telling us what our defect trends are over time. Let's take a quick look in the index itself. And if I type in index equals edge Intel, this is the index we set up for this demonstrator, you can see all the metadata coming in real time. So my 4 hosts as follows: my 2 PowerEdge nodes, my precision, and my VM. And you can see here then some of the defect data that's coming in. And again, it's just kind of general metadata information around the computer vision, the algorithm that's running on EII. And the most important thing I wanted to show you here, what we did when we coded up these connectors was make sure that the image data that's being written out to ECS corresponds to the image handle that's going into Splunk. So this will give us, you know, a fantastic governance capability over the data that we're sending back to our data center. So, you know, again, making sure that timestamp and file names match up to what's within Splunk. So a fantastic capability for kind of full data governance using Splunk Analytics. So folks, that's really a very quick view. If you would like to learn more about these solutions, I'd recommend maybe hitting the following links. So delltechnologies.com/Splunk for a good view of our ready solutions and the various different solutions we have in place with Splunk. Or delltechnologies.com/Edge if you want to learn more about our Edge solutions. And there's going to be a huge amount of announcements in this space at Dell Technologies this year. Also, to learn more about Edge Insights for Industrial or the Intel Edge Software Hub, go to intel.com/Edge. And if you want to learn more from Dell directly, do reach out to your account teams or email us at emergingtech@dell.com and we will pick it up for you. Thank you for your time today. I hope you enjoyed the presentation. And